Good afternoon, sir. Good afternoon, classmates. Our topic is Chapter 6. My name is Georgie de la Cruz. I am together with Ruesa Jean Delgado. First part will be reported by myself. Database and Information Management, the basis of business intelligence management. Course intended learning outcomes. After completing this chapter, students should be able to answer the following questions. What are the problems of managing data resources in a traditional file environment? And how are they solved by a database management system? What are the major capabilities of database management system, DBMS, and why a relational DBMS so powerful? What are some important principles of database design? Why are information policy, data administration, and data quality assurance essential for managing the firm's data resources? Organizing data in a traditional file environment. Information that is accurate is error-free. When information is accessible to decision makers at the appropriate time, it is timely. When information is applicable and suitable for the task and choices that for it, it is said to be relevant. Data management is crucial because of this. File organization terms and concepts. You can see the figure 6.1, which clearly illustrates a data hierarchy. The data are arranged by a computer system in a hierarchy that move from bits and bytes to the field records, files, and database. So you can see the illustration from the below button. Bit is the smallest piece of data that a computer can handle. Byte is made up of a collection of bits which stands in for a single character, which could be a letter, a number, or another symbol. Field is a collection of characters that form a word, a collection of words, or a complete number. Record is made up of number of linked fields such as the student's name, the course they took, the data and their grade, and file is made up of numbers of records of the same type. Okay, so you can see the examples in the illustrated illustration. Like the bit is the zero, byte, numbers and letters, and the field, the name, record, it has the name, course, date, and the grade. And the file is having all the information needed for the students. File organization terms and concepts. A database is composed of a number of connected files. Entity is described in a record. An entity is a person, place, thing, or event that is the subject of information that we keep and preserve. Attribute is a property or characteristics that characterizes as a specific entity. Example, an entity course has the characteristics of student, course, date, and grade. Traditional file environment controversies. One of the controversies is data redundancy and inconsistency, program data reliance, rigidity, inadequate data security, and the inability to transfer data among applications are the issues that occur. You can go and check figure 6.2. This is the typical traditional file processing. Redundancy and inconsistency in data is the presence of identical data in numerous data files resulting in the storage of the same data in multiple locations. It wastes store space and can result in inconsistent data. Example, in figure 6.1, the first illustration that I showed you earlier, the system may use student ID. Others would use ID instead. Some use the letters X and O. Some use the term extra big for the same purpose. Program data dependence is the relationship between the data that are kept in the files and the particular programs needed to update and maintain those files, making it necessary for data changes to occur when programs are changed. Not being flexible and lack of security. To compile necessary data elements in a new file, several programmers may need to work for weeks. Information access and distribution may be out of control because there is minimal data management control. Data availability and sharing issues. Different functional areas or portions of the organization cannot communicate freely with one another. Users may decide not to utilize their systems if they discover different values for the same piece of information in two distinct systems because they cannot trust the accuracy of the data. Data management using a database approach. Many of the issues with conventional file organizing are solved by database technology. A company, for instance, construct a single common human resources database rather than holding employee data in various information systems and different files for people, payroll, and benefits. Data Management System or the DBMS. It is a piece of software that enables an organization to consolidate data, manage it effectively, and give application access to the data contained in the system. It serves as a link between application and the actual data files. For example, an employee's name, social security number, health insurance coverage, for instance, might be needed by a benefits specialist for the HR. This data might be recorded by the payroll department. All of these views data are kept in single database, making it easier for the departments to arrange them, to manage them. Figure 6.3 Human Resources DBMs with multiple views. So this is what I have discussed earlier that employee ID, name, position hired can be used by the payroll or the benefits department. How DBMS address issues with the conventional file environment. DBMS lowers redundancy and inconsistency. It separates programs from data, allowing data to stand alone. Organization is able to centrally manage data, their use, and their security through DBMS. Relational DBMS is currently the most common type of DBMS for PCs, as well as for bigger system and mainframes, while DB2, Oracle Database, and MS SQL Server are relational DBMS for large mainframes and mid-range computers. Microsoft Access is relational DBMS for desktop systems. Database management system capabilities. The ability to manage, access, and organize data in the database is provided by DBMS. The data definition language, data dictionary, and data manipulation language are the most crucial. The structure of the database content can be specified using the data definition feature of DBMS. Data dictionary would be used to document this database information. Reporting and querying. To add, modify, delete, and retrieve data from a database, most DBMS contains a specific language called data manipulation language. SQL, also known as Structured query language is currently the most well known language for data manipulation. SQL is also used by Microsoft Access, but it also offers a set of user friendly tools for searching databases and assembling data from database into more professional reports. Figure 6.6 Access Data Dictionary features. It's, it illustrates the data dictionary capability that displays information about the size, format, and other characteristics of each field. Like the supplier table, the small key icon to the left of supplier number indicates that it is a key field. Database design. Understanding the links between the data, the types of data that will be kept in the database, how the data will be used, and how the organization will need to alter the handle data from a company wide perspective are all necessary before you can develop a database. Illustrated here in 6.8 figure is the query that would be used for constructing using Microsoft Access Query building tools. It shows the tables field and selection criteria used for the query. Diagrams of entity relationship and normalization. In order to satisfy corporate information requirements, the design process determines linkages between data and the most effective approach to organize data elements together. Complex data groupings must be simplified to reduce duplicate data pieces and uncomfortable many to many links in order to use a relational database model efficiently. Normalization is the act of taking large, complex collections of data and turning them into manageable, flexible, and adaptable little data structures. Referential integrity rules attempted to be enforced by a relational database systems to maintain consistency in the relationship between connected tables. Entity relation diagram or the ERD used by database designers to describe their data model shown in the next slide, which is figure 6.11. This diagram shows the relationships between entity supplier, part, line item, and order that might be used to model the database in the last figure. This is the last part of my presentation. Thank you for listening. Second part will be presented by my groupmate, Rowesa Jean Delgado.